Hi everyone, in this video we are going to talk about how we can draw Lewis structures. Right, so here are some examples and I'm going to walk you through all the individual steps. So first and foremost, let's look at the example of NH3. So the first step that you can do is to put the odd looking atom in the middle and arrange the rest around it. Right, the next step is to take note of charges, but in this case there are no charges around, so I do not have to work with charges at all. So the next thing that you need to do is to make sure that all the atoms in the outside are happy, alright, or satisfied, right, either with the duplet or the octet configuration. So we are going to look at hydrogen, and hydrogen has one valence electron, it needs one more, so I form a single bond, and single bond. And now I take a look at my central atom and see how many valence electron it has originally. Alright, and nitrogen is in group 15, so it has 5 valence electrons. It used up 3 of them to form 3 single bonds, so it has a lone pair of electrons left. And now I want to check if nitrogen has 8 electrons, and it is confirmed that it has 8 electrons, so this is the structure of ammonia. Right, so I can redraw it to show its shape, and this is how I can draw the Lewis structure for ammonia. Let's move on to the second one, SO4 2-. As usual, I'm going to put sulfur in the center, oxygens around, but now I have to put 2 negative charges in. Alright, and so if I give it 2 electrons, the more electronegative one will take the electrons in. Conversely, if I were to remove an electron, it will be removed from an atom who is less electronegative. Alright, so I'm going to take note of the 2- charge, and I'm going to give 2 electrons to separate oxygen atoms to spread out the charges. And now I will look at the individual oxygens and see how many electrons they need. So if we look at the oxygen atoms without the negative charge, they have 6 valence electrons, they need 2 more, so double bond, double bond. But each of these oxygens with the negative charge have 7 valence electrons already, so they will simply form a single bond. Now I'll look at this sulfur in the center. Alright, how many valence electrons does it have? It has 6 valence electrons. It has indeed used all 6 of them to form bonds, so it does not have any lone pairs of electrons left. However, if you count the number of electrons around it now, I have a total of 12 electrons around sulfur, and we need to ask ourselves, is it able to expand its octet? And if you realize it is in period 3 and above, so it will be able to expand its octet, and therefore I will keep the answer as such. Alright, and for some answers, they will actually draw a bracket, remove the negative charge, and put the charges outside. Right, but in our discussion, we can simply just put it here for now. Okay, so the next example is No2 Plus. So once again, I'm going to put N, O, and O here. And because positive charge means I have to remove an electron away from the less electronegative atom, so now my nitrogen only has 4 electrons left. So let's see how it can form bonds with oxygen. So oxygen needs 2 and 2 over here. So nitrogen has 4 valence electrons after removal of 1 electron, so it has formed 2 bonds with 2 double bonds each. Alright, so that's the first thing that you need to take note of. And after that, if I count the total number of electrons around itself, it has 8 electrons, so it is totally fine. So this is a structure of NO2. If you remove the positive charge and you put it outside, alright, this is how it's going to look like. And our final example is ozone, so I'm going to write O, O, O over here. Alright, and I'm going to make sure my oxygen atoms outside are happy, so double bond, double bond. And now let's take a look at the oxygen in the center. It is in period group 16, therefore it has 6 valence electrons. It used up 4 for bonding, there's a lone pair left. So if I look at all the electrons around it, I will realize that it has a total of 10 electrons, but because it's in period 2, it cannot expand its octet. So what is going to happen is that instead of forming a double bond, it will form a dative bond where it gives 2 of its electrons to the oxygen. So this oxygen here is satisfied, this oxygen here is satisfied, and the oxygen in the center has 8 valence electrons, which means it is also satisfied. So just take note that if you cannot expand the octet, you should change your double bond into a dative bond. However, if you can expand the octet, just leave it as the double bond. And that is how you can draw the structure of ozone. So if you want to draw it more accurately, it is of band shape, so you can draw it like that. And this is how you can draw Lewis structures. Alright, so this is very important because once you are able to draw the Lewis structures, only then will you be able to determine the polarity of certain molecules and the type of intermolecular interactions that they have. Right, assuming that you're talking about simple molecular structures.